Have you ever wondered why we write m for meter and n for Newton? That's because in chemistry and physics, even capitalization follows a rule. When a unit is named after a scientist, its symbol is written with a capital letter. For example, N for Newton, W for watt, and V for volt. On the other hand, if a unit is not named after a scientist, we use lowercase letters, like M for meter, S for second, and kg for kilogram. This distinction helps avoid confusion across scientific disciplines, from textbooks to laboratory reports. Let's say you're writing a force of 10 newtons. It should be 10 capital and not lowercase n, and never written as the word newtons in short form. It's a small rule, but it keeps the big world of science consistent and precise. Here's another point students often get wrong: how to write the full name of a unit. Even if the unit is named after a scientist, its full name is always written in lowercase. So we write Newton, not Newton, Pascal, not Pascal. Also, never use plurals in unit symbols. For example, we write 10 meter, not 10 meters. Why? Because in symbols, the plural form can confuse the measurement with a separate unit. Now, let's talk prefixes. C rules strictly allow only one prefix per unit. So, instead of writing kmw, which is incorrect, we use GW for gigawatt. And when combining a prefix with a derived unit like cubic meter, write it properly. For instance, kilometer cubed means 10 raised to 9 cubic meters, not 10 cubed into meter cubed. Chemists use units like joules and liters regularly, so writing them correctly is part of scientific accuracy. Now let's explore compound units, the ones made by multiplying or dividing other units. If you're multiplying two units, say Newton and meter, you can write it in three acceptable ways: n dot m, n cross m, or simply nm. What if you're dividing? This is where negative exponents come in. For example, velocity is measured in meters per second, which is written as ms to the power minus 1. Power, which is joules per second, becomes js to the power minus 1. These conventions help scientists avoid ambiguity in equations and data sheets. In physical chemistry, you'll often see joule per mole per Kelvin or J mol to the power minus 1 K to the power minus 1. It's all about writing clearly, not just calculating correctly. As we wrap up, here are a few more quick rules to always follow. First, symbols are never plural. So never write seconds or meters, just use S and M. Second, only one prefix per symbol. You can say gigajoule, but not kilomegajoule. And remember, when a prefix is attached to a symbol, it creates a new symbol altogether. For example, kilometer cubed means 10 raised to the power 9 cubic meters, that's a billion cubic meters. All these rules, from capitalization to prefixes, aren't just about grammar. They're about scientific integrity. In chemistry labs and exams alike, following these unit conventions ensures that your work is accurate, understood, and respected.